Hello dear children, hope you are keeping well. Hope you remember the things we discussed in our previous module, the rules for drawing images in convex mirrors. Let us have a quick recap. Rule 1. A ray of light that enters parallel to the principal axis appears to diverge from the principal focus. Rule 2. A ray of light that enters through the focus emerge parallel to the principal axis after reflection from a convex mirror. Rule 3. A ray of light that enters through the center of curvature will retrace its path after reflection from the mirror. And Rule 4. A ray of light that is incident at point P on the reflecting surface of a convex mirror will reflect making the same angle with the principal axis. So today in this module we'll use these rules and we'll draw the image formation in convex mirrors. So let's start. So children, here we have our convex mirror. The light falls on the bulged portion, that is the convex surface, and the coating is inside. And we know that when the distance of the object is changed from a convex mirror, then only the position and the size of the image changes. So there are two main positions of an object in the case of a convex mirror. That is from the point of view of position and the size of image. So the two positions where the object can be kept are, the first one, the object is kept at infinity. Second, the object is kept between infinity and pole. So now let us understand where do we get the image, or what is the nature and size of the image that is obtained when we keep the objects in these two particular positions. The object is kept at infinity. Children, you can see that the object is kept far away from the mirror. So this is our convex mirror, principal focus and center of curvature. So let us show the parallel rays coming from the object. This is our first incident ray, and let us show one more. Let us also consider a ray that is entering through here, or it is falling perpendicularly to the reflecting surface. So let us apply the rules. We know that a light ray that enters parallel will appear to diverge to the principal focus. So this is our reflected ray. Show the arrow mark, and for this we are showing the reflected ray as such. We are showing the dotted lines inside, and here is our reflected ray. In this case, the light ray reflects back to the same path because the angle of incidence and the angle of reflection is 0. Also, we can show the normal here, but this is enough here. So when the object is kept at infinity, in the case of a convex mirror, an image, a highly diminished or a point size virtual and erect image, is formed at the principal focus. So how is the image? It's highly diminished or point size. Where is the image formed? It is formed at the principal focus, and nature is virtual and erect. So with this we complete the image formation in convex mirrors. So children, we understood that when we keep an object at infinity in a convex mirror, the image is formed, or the position of the image is at focus behind the mirror. Size of the image is highly diminished or point sized. Nature of the image is virtual and erect. Second image formation, in convex mirrors, object anywhere between infinity and pole. So children, we have kept an object. We can keep it anywhere between infinity and pole. This is our pole. Principal focus. Here is our center of curvature. So the object we have kept anywhere between infinity and the pole. You can see the first light ray that is coming parallel to our principal axis. Let our principal axis be xx dash. And this light ray, we know according to our rule, it should appear to diverge from principal focus. So let us show this is our principal focus. So we will show the dotted lines. Then the reflected ray is this. Now the second light ray, it enters through the center of curvature and it reflects back along the same path. So this is our center of curvature, this point, and this is our object. So the light ray enters till here full lines, then we'll show the dotted lines and it is reflected back to the same path. So this is our incident ray and again it reflects to the same path. So two arrow marks here. So we can see that these light rays meet at this particular point. Actually they don't meet, but they appear to meet at this point. So here is our image. Virtual image. So a small virtual image is formed here. Let that be A dash, B dash. Student, let us also show the normal to the incident ray. So these rays obey the laws of reflection. So let this be the normal that is shown through the center of curvature, so that the angle of incidence, this is I, is equal to the angle of reflection. So children, when we kept the object anywhere between infinity and pole, we got a virtual image. We got a small virtual image between pole and principal focus. So we have shown this image in dotted lines because it's a virtual image. So the image is formed between pole and focus and the image is virtual and erect and it is diminished. So this was the second image formation in convex mirrors. So with this we finish the image formation in convex mirrors. When the object is kept between infinity and pole, that means anywhere between infinity and pole in a convex mirror, the image, what is the position of the image? Image is between pole and focus, that is between P and F. Size of the image, it is diminished, small in size as that of the object, and the nature of the image is virtual and erect. So let us understand. So in a convex mirror, when the object is kept at infinity, the image is formed. Where is the image formed? The image is formed at focus, that is behind the mirror. Size of the image is highly diminished or point sized. The nature of the image is virtual and erect. When the object is kept between infinity and pole of the mirror, the image is formed behind the mirror, that is between pole and focus. The image is diminished, that is smaller in size, and the image is virtual and erect. So what do we understand, children? That means in a convex mirror, wherever we keep the object, whatever be the position of the object in front of a convex mirror, the image formed by the convex mirror is always behind the mirror. It is virtual, erect and smaller than the object, or it is diminished. So that is why convex mirrors are used as rear view mirrors. You know, children, in vehicles like cars, trucks, etc., to see the traffic at the rear side or the back side, we use convex mirrors. Why? A driver prefers convex mirrors as rear view mirrors because of mainly 2-3 reasons. One is because a convex mirror always produces an erect image of the objects. Then it gives a wide field of view. In the place of convex mirrors, if we use a plane mirror, what happens? It gives a narrow field of view or a small field of view. The objects that are coming at the back or at the back side of the vehicle, it won't be much visible. That wide range of vehicles won't be visible. And also flat mirrors also, the case we told. If we use concave mirrors, concave mirrors give inverted images. So these are the reasons why we use convex mirrors as rear view mirrors. And also they are also used as shop security mirrors. So hope children you understand the applications of convex mirrors and the image formation in it. The ray diagrams that are to be drawn in the notebook. Image formation by a convex mirror for different positions of the object. So in that, the first one is position of the object, that is object is kept at infinity. You have to draw the ray diagram. And position of the object between infinity and pole. And after drawing the ray diagrams, you have to write the position of the image, size of the image and nature of the image. So after you finish the diagrams, you have to copy down the table 10.2 in page number 167. Hope children, you will do it.